Today we'll be working on the following problem. Let E be a Lebesgue measurable set in R1 with Lebesgue measure mu, and then mu of E is greater than 0. Now we define the sum set E plus E, defined to be the sum of x and y, in which both x and y are in E. Now we want to show that this E plus E contains an open interval. So pause the video if you want to work on this by yourself. Okay, so this is very similar to what we have done in the last problem, right? So in the last problem, in problem 6, we did E minus E case, where E minus E also contains an open interval. But in this case, we don't know what the open interval is, right? We want to find the end point of this. So again, we'll be using the lemma, right? So the lemma is like for all lambda between 0 and y, we can find open interval I from C to D, open interval, and then such that the measure of the intersection is greater than lambda times D minus C, right? So how do we use this to find the open interval which is contained in E plus E? So first, let's see if this, let's guess like what could it be, right? This open interval. So what are the two endpoints? So if E is this interval itself, let's say if E is this, then the sum of this is actually interval from 2C to 2D, right? So this interval, we know is centered at C plus D. Okay, so let's guess this. This is C plus D. And then we want to have some delta. A plus D plus delta. And then C plus D minus delta. So let's see if this is the interval we're looking for. Basically, we have we want to find delta, right? This delta is depending on lambda. So this interval, let's see, this interval is our J interval. So basically is C minus D minus delta and C plus D plus delta. Let's say this the interval. We want to find the C and D is determined by lambda, and then this delta also determined by lambda. But for any Z in this interval, and then there exists X and Y in E such that X plus Y equal to Z. If we can prove this, then we know every point J is contained in E plus E, right? So using the same approach as we did for our last problem, so we want to consider this two set, right? So this Z minus E and this E set. So basically this two set, if this disjoint, if this two set, we want to show this two set is not disjoint, basically. And now if they are disjoint, then this two set will also be disjoint. Right? So now if they are disjoint, then the measure of the union of this. I'll define this to be the A, this define to be the B. So the union of AB is just because they're disjoint. So it's the mu A plus mu B, right? And then mu A, if we see the mu A is Z minus this. So it can be right as minus E intersect E plus this Z. So because of the translation, so it's actually equal to the E intersect I plus. Now this is greater than 2 lambda times D minus C by assumption, right? So now we want to make sure these are non-empty, meaning like, okay, so now we know this set also this Z minus E intersect E, this set, clearly it is a subset of this. And then E intersect I, also a subset of this, right? And then this Z minus I, we know it is an interval, right? Z minus I, because I is an interval. And then this two endpoint can be easily see is the C plus D minus delta, and then minus D. And this could be C plus D plus delta minus C, right? Oh, this is C minus delta, D plus delta, right? C minus delta, and then D plus delta. And then this is CD, this is your I, right? So from here we have what? So we have this A and B, right? So this mu from this mu A B, but A is a subset of A is, so we have A equal to this is a subset for this, and the B is the intersection of E and I is a subset of that. So mu, the A and B union the measure 2 lambda D minus C, right? It's greater than this, but then this should be at most the bigger set Z, because Z minus I union I is at most this. So the measure is D plus delta minus C minus the endpoint, right? Which is D minus C plus 2 delta. So where delta is, so from here delta is bigger than 2 lambda minus 1 over 2 times D minus C. So from here, now we can pick lambda is 3/4. So we want to make sure 2 lambda minus 1 over 2 is greater than 0, right? And then delta, we can pick this results to be 1/4 of D minus delta. So, which means if we pick the lambda equals 3/4, then we find from this lemma we have a C and D, which is this, and then we have this inequality, right? And now we pick delta equal to 1/4 of this. Now we going backwards, this two set, meaning like because of the inequality over here, and then we know A and B, and then A and B cannot be destroyed, right? Because otherwise the measure of the sum will be strictly less than the D minus C plus delta from this inequality over here, right? So A and B is non-empty. If A and B is non-empty, then this is non-empty. Then we have Z minus E intersect E is not empty. In other words, there exists X and Y in E. X plus Y equal to Z. So what we have proved for any Z, that is C plus D. This J, right? So we define C plus D minus delta and C plus D plus delta is contained in E plus E. We're done.